can't even see? In 2015, the answer to this question started to be uncovered. Researchers found that the skin of an octopus is sensitive to light due to photoreceptor genes active in the skin. Even when the skin was detached from the body, it could respond to light and change the shape of its chromatophores. Scientists realized that an octopus can see with not just its eyes, but also its skin. But as the octopus body was evolving its color-changing defense mechanisms when it lost its shell 140 million years ago, another transformation occurred: the development of its large brain and nervous system. The photoreceptor genes in the skin work in connection with the octopus's large and complex brain. The octopus can change colors so fast because the octopus controls its chromatophores neurally. Other animals that can change color, like chameleons for example, take much longer because their color change is hormonally controlled. Hormones take time to get into the blood and distribute around the body. A color change can take over 20 seconds when controlled this way. Some researchers believe that color change in the octopus may be like breathing or blinking for us, something it can choose to do, but also something that can happen involuntarily. It can have awareness from its eyes and brain, but also throughout its body. The octopus nervous system is large like ours, but built with a different relationship between body and brain altogether. The common octopus has around 500 million neurons in its body. For comparison, humans have about 100 billion. Most invertebrates usually have much less. Snails have only 20,000. But cephalopods like the octopus score in the same range as many vertebrates, like cats, dogs, and parrots, more than any other invertebrate. And of their 500 million neurons, only a third are found in their brain. The majority are found in their 8 arms. And as strange as it sounds, this allows the octopus to, in a way, think with its arms. For a long time, scientists have known that a severed octopus arm can respond to stimuli an hour after being separated from the central brain. But a paper last year began to reveal the extent of this autonomy. Using video modeling, they observed the octopus as it explored objects in its tank and looked for food. The program quantified movements of the arms, tracking how the arms work together in synchrony, suggesting direction from the brain, or asynchronously, suggesting independent decision-making in each appendage. And they found that in the flow of information from the environment to the octopus, some information bypasses the central brain entirely. The suckers and arms can, in a way, think for themselves, allowing the octopus to analyze its environment extremely quickly and react with matching speed. Along with skin that can perceive and change color on its own, the relationship between brain and body in the octopus is full of blurred lines. And on top of this unusual neural layout and strange body autonomy, cephalopods are smart, extremely smart. And this is really what gives the octopus its alien-like status. They are so far from any other intelligent life on the tree of evolution, but still compete with vertebrates in their raw cognitive ability. Evolution invented intelligent life not once, but twice, in 2 completely different ways. In the evolutionary tree of life, we sit upon the branch of mammals. Nearby are the fish, reptiles, birds, and amphibians, the other members of the larger classification of vertebrates. This group is where we see all of the intelligent life we normally think of: humans, primates, dogs, cats, dolphins, and some birds. When we collect these animals and trace back to our common ancestor, it was likely a lizard-like animal that lived around 320 million years ago. Like us, this animal would have had a backbone, 4 limbs, a head, and a skeleton. It would have walked around, well adapted to land, and had a well-developed central nervous system. But to find where we split from the octopus, we have to travel much further down the branches, to around 600 million years ago. The creature we find there is a simple, flat worm. It had an extremely basic nervous system, and no inklings of what we would consider intelligence. As the evolutionary tree branched and diverged, intelligence blossomed on our branch of vertebrates, and totally separately in the cephalopods. And with the cephalopods evolving before any of the intelligent vertebrates, it's likely that they were the first intelligent animals that appeared on Earth. But what actually is intelligence? How can we identify or even measure such a thing in an animal so different from us? In humans, intelligence is commonly defined as the ability to think abstractly, understand, communicate, problem solve, learn, form memories, and plan actions. This is usually measured by intelligence tests which can be given a numerical value. But we can't give a standardized test to an octopus. We can only observe their behaviors.
Why the cephalopods? Well, they're the most interesting mollusks in terms of behavior. No question.
To learn more about the depth of octopus intelligence as researchers currently understand it, I spoke with Jennifer Mather,